What if you could just draw an idea, and poof, it instantly becomes a working piece of software? Well, today we're diving into a really cool piece of tech that does pretty much that. It acts like a bridge between your creative spark and the cold, hard logic of a computer.
Come on, you know the feeling. We've all been there, right? You get this flash of inspiration. You grab whatever's nearby, a napkin, a whiteboard, and you map out the perfect logic. But then comes the hard part. Translating that beautiful, simple drawing into hundreds of lines of strict, unforgiving code.
And this, right here, is where it all begins. This is what an idea looks like, in its purest form. It's often a bit messy, it's very human, and it's how so many incredible pieces of software start out, as just a simple map of boxes and arrows. And that's really the heart of the problem. There's this massive gap, this chasm, between the way we think visually and the way computers need to be told what to do. It's a translation issue. And honestly, it's a gap where countless brilliant ideas have just fizzled out.
Now, people have been trying to solve this problem for a long, long time. But the early attempts, while they were totally innovative for their day, were, let's face it, pretty clunky and restrictive. Let's take a quick look.
So here are a couple of the early pioneers, systems called Baxi and Raptor. And look, these were important steps, especially for teaching programming in a visual way. They let you build a flowchart with your mouse, but man, it was slow. And they had no idea what to do with a messy, hand-drawn sketch like the one we just saw.
And these older systems ran into some pretty big walls. For one, you're usually stuck with just one programming language. You also had to use their perfect, rigid shapes, no freehand drawing allowed. And the real kicker? You couldn't actually test the code you just made. It was close, but it just wasn't the seamless experience we were all dreaming of. Okay, so if that was the old way, what would a modern solution even look like? Well, it would have to be smart, it'd have to be flexible, and super powerful. It would need to be less like a clunky tool and more, I don't know, like a universal translator for your ideas.
And that brings us to the hero of our story today, the Dynamic Flow-to-Code Generator, or DFCG for short. The keywords to focus on here are multimodal deep learning, which is just a fancy way of saying it understands both pictures and text, and multi-language, which, as you're about to see, is a total game changer. So this is it. This is the whole magic trick laid out from start to finish. It all starts with one simple thing, a picture of your hand-drawn flowchart. That picture then gets sent through this super smart pipeline. It gets processed, the shapes are detected, your writing is read, until at the very end, out pops clean, working code.
So how does it actually pull this off? How does it turn your scribbles into real code? Well, the whole thing really breaks down into 4 key steps. Think of the AI as having 4 different jobs. First, it puts on its glasses and acts as your eyes, finding every single shape and arrow in your drawing. Then, it becomes a reader, using something called optical character recognition to read your handwriting. Next, it becomes a logician, building a sort of digital map of how everything connects. And finally, it becomes the programmer, translating that logical map into perfect code.
And check this out. This is that first step in action. Look at how it correctly identifies and labels every part of the drawing. You can see the process boxes are outlined in magenta, the decision diamond is in cyan, and it even traces the arrows in green. This isn't just guessing. This is the AI deeply understanding the structure of your idea.
Okay, so the technology is obviously impressive. But in the world of programming, only one question really matters. Does it actually work? I mean, how accurate is this thing?
And this is absolutely crucial, because in coding, being 99% right is often the same as being 100% wrong. A single misplaced semicolon can break an entire program, so the code this thing generates has to be flawless.
And when you put the DFCG up against the older methods, well, the results are pretty stunning. Those older systems, they topped out at about 78% accuracy, which is okay, but the DFCG system hits 96%. And let me tell you, that jump from 78 to 96 is the difference between a cool but frustrating toy and a tool you can actually rely on to do the job.
So what's the secret sauce? How did they make that leap? Well, this quote from the research paper explains it all. Instead of going straight from the picture to the final code, the DFCG first builds this pure, logical blueprint of your idea. It perfects that blueprint first, and only then does it translate it into code. That middle step, that blueprint, that's the key to the whole thing.
So it's accurate. We know how it works. But the real question is, why should we care?
what does this technology actually mean for people who write code every day, or even for people who are just trying to learn? This is where it gets really exciting.
It all boils down to one single powerful number.
4. Because from that one single flowchart you drew, the system can instantly translate your logic into 4 of the biggest programming languages out there: C, C++, Java, and Python. You draw it once, and the DFCG just speaks all these languages for you. That kind of versatility is just a massive leap forward.
And the implications here are huge for everybody. If you're a professional developer, this means you can prototype ideas at lightning speed. If you're a beginner, it's this amazing learning tool that visually connects your logic to the actual code. And for everyone, the system has a built-in environment where you can run and debug the code right away. It completes the whole cycle, from idea to execution, all in one place.
So I'll leave you with this thought. What if the biggest thing standing between your next great idea and a real working prototype wasn't a keyboard, wasn't a bunch of complicated software, but just a pen and a piece of paper? Imagine the possibilities. Imagine what you could create.